to it? No, it doesn't work. And because it's already folded into the signal. So it should be analog filter before A to D converter. Alright, so that's one thing that I hope you to remember. Right, and then let's move to the installation of geophones. And right now, it looks like geophone is standing by itself. Actually, the soil is surrounded by that. It's holding it tight. So probably if you want to come in and hold it and try to shake it, you see it's not moving. It's pretty stiff. And it is very important that we are dealing with low frequencies. And then if it is not, if it is rattling a little bit, and then the ground vibration is rattling also the geophone. So the geophone signal you see is kind of rolling signals. So it is very important to have that. So some people, Mr. Huang asked me about using the spike, and some geophones coming with the spike as a model. Yeah.
Usually they use me.
Oh yes, and easy to use it. Actually, what they do is they have it and then push it.
And that suffice for this. The usual geophone that has a spike. Can it suffice for this? In case we don't have this,
no,
we cannot.
I don't recommend to use a spike. And sometimes if the ground has lots of boulders and cobbles and something like that, and it is not good to holding it tight. So I have tested several times, but it looks like good in the beginning when I shake it and easily moving. So it's not good. So what I'm doing right now, I got rid of all those spikes, and instead of it, I have a flat base, and then dig the soil a little bit, and then have a good material, soil, and then use it like a glue. And then if that does not work, and then I have a weight, like about 1 kilogram weight on top of it. So it's like a weight coupling. So that's what I do. Alright, so that's the thing. Okay, and then in terms of setting the geophone, I think we are fine, and then also the connection should be fine. And then I explained performing the test a little bit later. Okay, before I move to data acquisition. I hope you remember there are two different versions of SASW. The conventional one, the original one is CMP, which is common midpoint. And so in this case, when we want to go about 20 meter profiling, and you want to measure down to 20 meter, and then basically this is rule of thumb, and your receiver spacing should be 20 meter apart. And so starting wise, and then you may want to use 1 meter interval, and then 1 meter, and then 2 meter, twice it, and 4 meter, and then 8 meter, and 60 meter, something like that. And then we have to move the geophone away every measurement. But this one, to make things easy, and then it looks like it does not have long DNC cable at this moment. So rather than that, I like to go to CAP, Common Array Profiling, SASW. That means that I fix these two geophones, I move source away. Okay. So in that case, and then I measure the material between two geophones throughout. And then when I have a source far away, for say 20 meter away from this, I can go down to 20 meter too. So today we are going to use that scheme for the demonstration. Okay. So far, any questions? Any comments?
Just for when we use the reflection, if we want to go to 10 meter, we must spread 50 meters. With this one, 10 meter, we will spread 10 meters.
Geophone spacing?
Yeah.
CMP, you may want to use the same, the distance as the depth. Yeah, depth you want to profile. But this one, CAP, CAP SASW. In that case, typically I like to use about 2 or 3 meter receiver inner spacing, and then move the source away, but the source should go far away. And then because we are worried about near field effect,